Hello everyone. For this tutorial video I like to talk about surface integrals, which are integrals used to compute surface areas explicitly instead of volumes beneath a curve. The formula for a surface integral is surface integral represented with a double integral with a capital S beneath it of a function of x, y, and z with respect to change in surface equals a normal double integral with a d beneath the two integral signs, where we represent z as a function g of x and y, and the surface is given by the surface area formula we found earlier times the change in the cross-sectional area. And there's also a form in parametric equations that involves a cross product like so. We express f of x comma y comma z instead as f of the parametric surface given by the parametric equations, and turn the change in surface area instead to the cross product of the vector with u times the vector with v times change in cross-sectional area. And we can actually verify that the cross product is exactly equal to the surface area formula we found earlier by simply doing the cross product computation. So if we're given a specific problem such as evaluate the surface integral of 6 times x times y, and s is the portion of x plus y plus z equals 1 in front of the yz plane, and that lies in the system where x, y, and z are all positive, called the first octet. We would first express x as an equation in terms of y and z because we are given it is in front of the yz plane. Graph out the function in 3 dimensions, but then look at a cross-sectional area of it in 2D, and see that y is limited between 0 and 1, and z is limited between 0 and 1 minus y. We see, even though it may not be explicitly in the formula given above, we can rearrange it to express x as a function of y and z instead, and do the appropriate replacement. We now compute the double integral using that formula, making sure to do the appropriate step of replacing x with the equation we found, and then simplifying the work using algebra methods we already know, then plugging in the limits for y and z found, and then finally doing it as a normal double integral, and we get a final answer of square root of 3 over 4. Now that we have figured out how surface integrals work in general, we can figure out surface integrals of vector fields next, similar to how we figured out line integrals of vector fields after we figured out line integrals in general. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.